So good morning and welcome all students to the fifth class. And this is Circular Dynamics lecture number 7. Lecture number 7 is what we are dealing with here. In the previous lecture, as you can recollect, we had started motion in a horizontal circle, motion in a plane, and we had seen some examples of motion in a horizontal circle. I think the first example was a block which was attached to a string. We had solved that problem of a block attached to a string, isn't it? So, in today's class, what we'll do, what we will do is go ahead and see two or three important motions which are going to come in your NEET exam, two or three important points, two or three different categories of motion of an object in horizontal circle. And the first one in this category, we have done two or three in the previous class. The first one in this category, number one, is conical pendulum. Conical pendulum. The first one in this category is conical pendulum. I'm not sure if you have heard about this term, but I'm pretty sure that you have heard about the term pendulum, a simple pendulum, a string, you have a mass attached to it. This end is fixed. I hope you can see this. This end is fixed. Here you have a mass attached, and then you move it just like this. This is simple pendulum. Have you all seen this simple pendulum? Yes or no? Online class, offline class. We have seen a simple pendulum. This is how it moves. A simple pendulum. I will draw it here. String, a bob attached to the string, and this is how it moves. It goes up, reaches this maximum point, then it comes down, and it reaches the maximum height on this side. We are also going to study this motion, but this motion, as you can see, if I look at gravity, gravity is acting downwards. This is a motion in a vertical circle. This is not a motion in horizontal circle. This is simple pendulum. This gentleman is simple pendulum, and this is motion in vertical circle. I hope everyone can understand this. This is simple pendulum and this is motion in vertical circle. We are not studying it right now. Motion in vertical plane, or it is motion in a vertical circle. We are not going to study this now because we are studying motion in a horizontal plane. Now the question arises, if this is simple pendulum, this gentleman is simple pendulum, how does a conical pendulum look like? What is the difference between a simple pendulum and a conical pendulum? Anyone can give me any thoughts on this? What is a conical pendulum? If I have to draw a conical pendulum, I will start like this. Tongue, 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 tongue. And a conical pendulum, well, what does it have? Again, it has a string. It's a pendulum, it should have a string. One end of the string is tied, so this is tied. Other end of the string, you have a bob attached to it, so this is a bob which is attached to it. What is the difference? A simple pendulum moves like this. Ting, 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 ting. You might have seen the London Tower. You have a pendulum clock over there. Ting, 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 ting. That's a simple pendulum. Ting, 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 ting. This is simple pendulum. Motion in a vertical circle. This is simple pendulum. What is a conical pendulum? I have this pendulum like this. I take it at an angle and then I turn it. Doom, doom, like this. Now this is motion in a horizontal circle. So basically from the vertical, if I call this line as the vertical, the pendulum is at an angle and then it moves like this. Is everyone understanding what is happening here? Is my demonstration clear? So I just take out this vertical line. The pendulum is at an angle and then go dang 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 dang. This is your conical pendulum. Can I have some raised hand that we understand how does a conical pendulum look like and how does it go? Do we have an understanding of this? Can I have some raised hands? Conical pendulum. Aviram understands it. What about the others in the class? So how do I draw it on a sheet of paper? This is my pendulum. Tung, 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 tung. This is my bob. Tung, 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 tung. It goes inside. From the other hand, it comes outside. So this is how it looks like. Dung, 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 dung. Oops. I need to correct the diagram. Why it is not getting rubbed off? Okay, it will take a lot of time for it to get rubbed off. So I'll just draw it once again. This is the bob here, and then it goes like this. Dung 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 dung. This is how it goes. So it goes inside from here. The velocity is into the boat. So I draw it like cross into the boat. And from this side, it comes out of the board. I hope everyone understands this. So this is coming out of the board, out of the board, out of the board. That's why I've drawn it with a dot. This is how a conical pendulum looks like. Tung 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 tung. The length of this string is L. The length of this string is L, and this string is at an angle theta. If I draw the free body diagram, it's better I don't draw the velocity upwards because it might confuse you. So I'll just draw, not to draw velocity upwards and downwards because it will confuse you. This velocity means it is coming out from here. This velocity means it is going inside. Do we understand this? Can I have some reason? I told you about the dot and the cross. When you see a dot, something is coming towards you. It's like the headlight of a train ka engine. When the engine is coming towards you, you see the big headlight. Dot or the arrow, if something is hitting you with an arrow, you will see the tip of the arrow. Dot is coming towards you. Cross is going away from you. The last bogie of the train always has a cross. Cross going away, dot coming towards. So I've assumed that it is moving like this. Dung 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 dung. Goes like this. If I draw the free body diagram, the weight mg is always downwards in the vertical plane and the tension T is like this. Do we all understand this? Can I have some raised hand that we understand this, sir? Everyone understands this? Well done. Now this.
Understood, sir.
Well done, beta. Then this is the radius of the circle. Do we understand this? This would be the center of your circular motion. This is a horizontal circle. Dung, 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 dung. It has a center. This is the center, and the radius is this much. This is the radius r. The length of the string is given by L. So this is L and this is R. Do we all understand L, R? Can you draw this diagram? I'll give you a minute to draw the diagram. What you have to draw? You have to draw the conical pendulum. You have to draw the motion. You have to draw the velocity. From one end it is going in, from the other end is coming out. You can do the reverse of it. From this end it can go in, from this end it can come out. Doesn't matter. It depends on how it is moving. If it is moving like this, dung 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 dung. From this side it will go in. From this side it will come out. If it is moving like this, dung 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 dung, then it will go in from this side and it will come out from this side. Doesn't matter. It only depends on how it is going. I always rotate it like this. Dung 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 dung. So it always go inside from here and outside from there. Then you have the length of the string L. Then you have R, radius of the circle. Then you have tension T in the string. The angle between the vertical and the string is theta. The weight is mg. You have to draw it. I'll give you a minute and then we shall begin the explanation of the same thing. A minute to win it. I hope everyone has drawn this diagram. L, length of the string or length of the pendulum. R, radius of the pendulum. Theta, the angle. T, the tension. Mg, the weight. From one end, velocity is inside. From other end, the velocity is outside. What we are going to do now is understand how you can get the values of the unknown. The unknown here are T and maybe V, depending on how the question is framed. So we will get a relation between all these quantities and you will note down those relations. You may not have to do the entire work every time you get a question on pendulum. If you just remember these shortcut formulae, you would be able to tackle any question that comes in this conical pendulum. So what I'm going to do now is take you there and we will now solve. This is given in the form of a question. We'll do it in the form of one particular type of problem. So you have a conical pendulum having a bob of mass m suspended from the ceiling through a string of length L. So mass m and L is given. The bob moves in a horizontal circle of radius r. So they have given you the radius r. Sometimes the angle theta is given. Sometimes radius r is given. Sometimes length is always given. Out of the radius of the circle or angle theta, something would be given to you. Don't worry, whatever is given to you, you can find the other thing very, very simply. Here they was, what is the angular speed of the bob? Angular speed, that means omega. And the tension in the string, that means T. Basically, they can ask you anything. Giving you some of the quantities, they can ask you the other quantities. Don't worry. If you know the relation between all of these quantities, which is very simple, you should be able to solve the entire problem. I hope I am being clear. So now, first things first, let us first apply plane trigonometry over here. Plane trigonometry, you look at this angle is theta. I have called the other angle is theta. Doesn't matter, both the angles are theta. This angle is theta, you can call this angle also as theta. Both are same. It will come out and it will go in at the same angle. This length, this side is given as L. This is the radius of the circle. They have drawn it on this side. The other side also the radius is same. And this is H. You can apply plane trigonometry over here. Plane trigonometry, you can find out the value of sine theta. Sine theta will be equal to R by L, or you can write R as L sine theta. Do we understand this? Can I have some raised hand? R, the radius of the circle, will be equal to L times sine theta, because sine theta is nothing but equal to R by L. perpendicular divided by hypotenuse. On similar lines, you can write cos theta, which is base upon hypotenuse. Base is h. So you can write cos theta as base upon height, base upon hypotenuse h by L. You can find out the value of h from this right angle triangle. Remember, L square will be equal to h square plus r square. Normally, h is never given, so you can eliminate h from here. They've eliminated h from here, so cos theta becomes h by L. H is root over L square minus R square divided by L. So this is the first step. You may be asked any of these quantities. So this is the first step which comes from plane trigonometry, and I hope everyone is noting it down. This is the other way in which you can write this. So these are a series of 2 or 3 formulas that we have derived. We have not derived it. This is plain simple 9th standard, 10th standard trigonometry that we have applied over here. I'll give you a minute to note down these. You can call this as formula number 1. You can call this as formula number 2. You can call this as formula number 3. You can call this one as formula number 4. You can call this as formula number 5. With the diagram, you only need to add one h, which is the vertical height. I'll give you a minute to note this down, and I'll be back after a minute. I hope everyone has noted this down. Then there is a few things that you already know. The forces on the particle. One is T, tension along the string, like this. The tension is already drawn here. And the weight mg, which is vertically downwards. It is always vertically downwards. No prizes for guessing this one. Now, what we are assuming here, what normally happens is this particle is going to move like this. Dig, 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 ding, 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 ding. It is going to move with a constant speed v from one end. As you can see in the diagram here, it will go inside from this end, cross v, and it will come outside from this end, dot v, cross v and dot v. Do we all understand this? Can I have some raise hand that we understand this? From one end, it will be going inside, and from the other end, it will be coming outside. Now, what I'm going to do is I'm going to rub something off so that I can now do something here. Okay, this has been rubbed off. Now, the diagram that you see is all clear and clean. So what I'm going to do here is just change the color of the pen. Okay, from here, it is going in, cross V, and from the other end, it is going to come out dot V, and it is moving like this, as you can see. Dang, 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 dang. Now, I am going to make equations. Now, remember, I have to make equations along 3 axes. The first axis is tangential along the path of the circular motion. Now my question is there any force in the tangential direction? Tangential direction is the direction like this, dung, 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 dung. Along this circle, is there any force acting on the bob? Along this circle, is there any force acting on the bob? And what is your opinion about it? Is there any force acting in the tangential direction? Can anyone tell me this answer? Is there any force acting in the tangential direction? That is the first equation that we have to make. Can anyone tell me, is there any force acting on the tangential direction? And there is a hint here, which I am going to put it in a square. This is the hint that I have put it in the red square, rectangle, not square. Can anyone tell me, is there any force in the tangential direction? Waiting for your answers. Online class, offline class, Abhiram and the other students. Is there any force in the tangential direction? No, there is no force in the tangential direction. And because we have already stated that it is moving with a constant speed, there is no tangential acceleration. Only tangential acceleration can change speed. Speed is constant, no tangential acceleration, and hence, as you can also see, one force is like this, other force is like this. There is no force in this direction. Tangential force is zero. That is my first axis. What is my second axis? Along the center, towards the center. Now, is there any force towards the center? You will say, no, sir, there is no force towards the center. But hey, wait. This tension T, this tension T can be resolved into two components. This tension T can be resolved into two components. The first component is like this in the vertical direction, which I have drawn it by green. The second component is which color? Blue. Is like this, which is in the direction towards the center. Now, I would ask you which component is which. To understand which component is which, you must understand that this angle is also theta. This angle is theta. This is T. Can you tell me which one is the green component and which one is the blue component? Green component is in the perpendicular direction of motion. Blue component is in the direction towards the center. I am waiting for your answers. Which component is which? Remember, this is T and this is theta. So this component, oops, should I not write here? Because then it might come here. So this green component becomes my T cos of theta. Do we understand this? That my green component becomes T cos of theta. If the green component becomes T cos of theta, then the blue component becomes T sine of theta. Do we all understand this? Can I have some raised hand that we understand this? Yes, sir. This is T, this angle is theta, so this becomes T cos theta, and the other one becomes T sine theta. We studied in the chapter of vectors. Remember, this is physics. Whatever you study in chapter number 1 will come in the last chapter of your last topic. And that is why physics becomes tough. Do we all remember this? T cos theta, T sine theta. Can I have some reason that we understand this? T is resolved into two components. Remember, we are just following the steps. Draw the free body diagram. Resolve force into three directions, two directions, three directions. Then you write the equations. FC will be towards the center. Do we understand this? Yes or no? Can I have some raise hand that we understand this? Okay. Now, can you tell me the second equation? The second equation is in the centripetal direction. FC. How much is FC? Can anyone tell me? Opening your eyes, looking at the diagram. Everything is in the diagram. Can anyone tell me how much is FC? How much is FC? How much is FC? How much is FC? And yes, the correct answer is FC is T sine theta. Do we all agree on this? T sine theta is the only force which is towards the center. Whether you look it from this end or you look it from this end, it will always be equal to T sine theta. And this T sine theta can be written as M into omega square into R, where R is this radius, or you can also write it as M V square by R. Do we all understand this W equation? Can I have some raise hand that we all understand this blue equation, sir? Blue equation is in the direction of the center of the circular motion. This is the centripetal equation. If we have understood W equation, then we have to make the third equation. And the third equation is, oops, wrong color. I'm very particular about colors. I hardly recognize color, but I'm very particular about them. Third equation, the motion is taking place in this horizontal plane. The third equation is in the vertical plane. I would be very pleased if someone tells me what is the equation in the third axis, the perpendicular axis. What will the equation look like? I'll give you a minute to think about it. What is the equation in the perpendicular direction? A minute to think about it, and at the same time, write whatever I have illustrated or explained just now. If you have a problem, you can always come back. If you're watching recording of this lecture, you can pause here and you can go through this and tell me what is the third equation. Third equation in the perpendicular direction. A minute to write it. I hope everyone has noted down the equations that we have made. The red equation in the tangential direction, the blue equation in the centripetal direction, and what is the green equation? Remember, the green equation is in the perpendicular direction of circular path, which is vertical direction right now. Nothing is happening there. No motion is happening there. Forces must be balanced. T cos theta will be equal to mg. I hope all of us understand this. In the perpendicular direction, no motion, forces will balance. T cos theta will be equal to mg. I'll give you a minute to note down all the equation. Equation number 1, equation number 2, and equation number 3. I hope everyone has noted down the 3 equations. Now, once you have noted down the 3 equations, you know the basic relation. Now, you just have to multiply, divide, eliminate some terms, and you can get the values of all the things, all these quantities, T, L, R, theta, mg, velocity v, angular velocity omega, in terms of the other quantities. So we are not going to derive all those. What we are going to do is just simply write the results that we get. So we'll just go through them, how it is achieved. I've already told you. The first equation is T sine theta is mv square by r. We know this. T cos theta is equal to mg, equation number 2 or 3, whatever you call it. If you divide 2 by 3 or 1 by 2, whatever, you get the value of tan theta as v square by rg. So this becomes your first formula. No, you've written 5 formulas before, right? You've written 5 formulas before. Sine theta is L by R, cos theta is H by L. So this becomes your formula number 6. Tan theta is v square by rg, where r is the radius. From here, you can find out the value of velocity v. Velocity v becomes root over rg tan theta. You can call this as equation number 7. It is same as equation number 6. Equation number 6, it is given in terms of tan theta. Equation number 7, it is given in terms of v. Doesn't change anything. Doesn't change anything. Then you can find out the value of omega. Omega is v by r. So this becomes your equation number or formula number 8. You can also write this formula number 8 as g by h. You can also write this formula number 8 as g by L cos theta. You can also write it like this. I hope you understand the same thing. Same thing is written in different forms. Now you'll say, sir, so many formulas, how will I remember? No, you just need to remember one. The other are coming from simple common sense. If you can remember all, well, you would be scoring very highly, pretty highly in the NEET exam, because NEET exam is more about your speed and your memory rather than your concepts. Given sufficient time, you should be able to solve all the problems. Should not be a problem, but you will have to solve the problem in the examination hall very, very fast. Now, how do you do it very, very fast? Sometimes R will be given to you and theta will be given to you. So you can use the formula number 1. Sometimes H is given to you, nothing else. So you have to use formula number 2. Sometimes L and theta are given to you, formula number 3. Sometimes L and R are given to you, formula number 4. All these formulas are derived from each other. If you remember them, you can do the answer quickly. The other student who does not remember them will have to first write the original formula and then derive the other formula. That will take some time. And that is the difference between the toppers and the not so toppers. I'll give you a minute to note it down, the different equations and the different variations of the same formula. I'll be back in a minute. Note it down. Well, I hope everyone has noted this down. Yes or no? Everyone has noted this down? Okay, then there is one last thing that you must again remember, the value of tension T. So from equation number 2, this equation, you can write tension as mg by cos theta. T cos theta is mg. So T becomes mg by cos theta. So this becomes your formula number 9. If you want to call it formula number 9, or this is simply equation number 2 or 3, whatever was said. Then you can put the value of cos theta from here. From the first equation, second equation, you get the value of T as mgl divided by root over L square minus R square, or you can use T sine theta is equal to mv square by R. So you can also write T as mv square by R sine theta. Do we all understand this? Can I have some raised hand that we understand this, sir? And we understand that these may be looking so different formulas, but they are simple. We just derived them from 3 equations that we made, and we derived them from simple, plain trigonometry of 9th and 10th standard. Nothing so spectacular about it. We just used simple concepts and derived simple results. I will give you a minute to note everything down. I'll also open up the class for any doubts that you have. 1 minute, note it down. Any doubts, please ask. Well, I hope everyone has noted this down. I can also write this formula in various ways, right? So I can write, remember T sine theta is also equal to m omega square R. From here, I can derive a different formula for finding out the tension. T is m omega square R divided by sine theta. See, one formula, how many formulae I can derive. Now, look at a very important thing here, and you will be amazed. Beauty of doing things with your own hands. This R by sine theta is nothing but equal to the length of the string L. R is L sine theta. So R by sine theta is L. So I have another formula for tension. I have another formula for tension here. T is m omega square L. That is what I tell you. The more you work harder, you will get different types of formulae for the same thing, and then you will have so many formulae. If you can remember them all, you will score very heavily. And that is what most of the teachers say, I have got shortcuts with me, I'll tell you shortcuts. These are not shortcuts, these are just derivation, in how many different ways you can write one formula. So I've told you all the possible ways in which you can write the formula for tension in terms of mg and cos theta, in terms of m and v, in terms of m and omega. I don't want to burden you with all these formulae, but I have given you the entire stock. And again tell you, if you just remember t sine theta is mv square by r and t cos theta is mg, all these formulas are derived from there only. So either you remember all of these or you remember just two. The choice is yours. But again, as I said, NEET is a problem with speed. They only check your speed, nothing else. I'll give you a minute. Don't note this down, and then we'll move on and solve one problem on this, and we'll be done with this class. Well, I hope everyone has noted the various formulae. Again, I leave it to you. Do you want to remember all the formulae? Welcome. Very happy. If you can do with two formulae, happy as well. Very happy as well. But then it will take some time for you to derive those. Now, we'll solve one question, and trust me, these are the type of questions that you will get in the examination hall. So I'm hoping to get some answers from you on this question. And here is the question. Example number 20. A string breaks, oops, under a load of 50 kgs. A mass of 1 kg is attached to one end of the string, 10-meter long, length is 10 meters, and is rotated in a horizontal circle. Tung. So this is simple pendulum. No, not simple pendulum. Conical pendulum. Calculate the greatest number of revolutions that the mass can make in 1 second. So basically they are talking about frequency, number of revolutions in 1 second without breaking the string. Oops. What we have done is completely different. And it seems like the question is completely off the circuit. Oops. String breaking? Oh, how? Why? No. That is where you have to apply some of your brains. If you have done conical pendulum, every problem we have done, and we'll prove it here with this problem. Gives you a minute to think about it. You might be encountering problems where string breaks. So this is one problem in that category, string breaking. So breaking weight of the string or breaking mass of the string is given as 50 kgs. That means the maximum tension in the string is given to you. Maximum tension that the string can hold. That is the hint. A minute, 2 minutes. I hope everyone has tried this question. Now, this question may look like out of syllabus. Oh, it's out of syllabus. No. It is not out of syllabus. Simple things you have to apply. What all things are known to us? T, M, length of the string L. You have to find F. We don't have any formula for F, but we have formula for omega. And omega is 2 pi F. See, what we study in one particular chapter in physics, that again that thing comes in the future chapters, and that is why physics becomes tough. It is not tough. It relies on what you have done in the past. So physics is a way of life. You only are as good as what you were What you have done in the past, that affects your future. That is physics. That's how physics works. T is known, M is known, L is known. You have to find omega. Which one you have to apply? If you can get it in a jiffy, faster, you get into the top hundreds. If you don't, you struggle. I can't help it. So the solution is pretty damn simple. Omega is 2 pi f. All of us know it. Maximum tension is 500 Newton. It was given 50 kg in mass. You have to convert it into weight. 50 into G, 500 Newton. That is the maximum tension, T max. L is R sine theta. Now, R is L sine theta. Don't matter. So, we have already derived this result. T is equal to M omega square L. The last formula that I gave you. Now, this is how T and omega are related to each other. If I want maximum omega, T must be maximum. So, I just put T max. And here I have omega max. Allah, I know T max. I know T max. This one. I know mass. This one. I know length. This one. I can calculate omega. Once I can calculate omega, omega is 2 pi f. Omega is 2 pi f. Your f here is written as n. Call it f frequency. Frequency becomes omega divided by 2 pi, and your answer becomes root over 50 divided by 2 pi revolutions per second. That is how you apply what you have studied. Might look complicated. It's not so complicated if you understand the problem. If you understand that you have done conical pendulum, you must be confident that sir has taught us everything that is needed about conical pendulum, and it is a fact. I've told you everything that you need to know. Now, you'll have to use your brains. Some question may be straightforward. They will just ask you what is the tension. They'll give you omega, they'll give you L, they'll give you R. Put the formula, get the answer, stay happy. Some question may be somewhat twisted. They ask a simple thing, but they twist the question. There, apply your brains. So I'll end the class on this note. We've done one more case of motion in a horizontal circle. We are still not done with horizontal circle. The next class, we'll try to wind it up. 2 more cases left. That will encompass everything that can ever be asked in your exam. So until that time, today is Wednesday, Thursday. We meet on Saturday with those 2 topics, and then we'll wind up horizontal circle. If you have any doubts, you can always come up to me. I'll end this class. Stay in your hostel, stay safe, get vaccinated, follow all precautions. That's the only way we can defeat this virus. End this class. Have a good day. Enjoy yourselves.